So basically, this is the DCEM work group that is data center efficiency metrics work stream output. I'm representing the whole team. There's a lot of people, Eric, Dylan, Shruti, Don, John, David, a lot of people, Gobi, Deborah, a lot of people contributed to this work. So basically the way I'm kind of organized, maybe there is a lot of text here. So I'm going to give you some background and really like give you the what is the metrics and why we have to kind of look at all the different elements within the metrics and how are we going to approach creating a sustainability profile that we can able to put on the system, the work that we are going on into the materials. So basically, if you look at the problem, right, today we are using PUE is the golden metrics for doing data center efficiency. And if you look at that one, basically what you're taking is you're taking a data center energy, and then you're kind of giving that, providing IT energy from the data center energy. What you're doing is you're basically taking the whole the data center energy coming into the data center, and you're dividing by the IT energy to get the PUE. So the number is going from 1 to infinity. So if you are saying PUE of 2, that means you're 50% efficient. But mostly your PUE is approaching 1 right now, right? So the metrics what we want to define actually like instead of looking at tops down, that's what PUE is doing. What we want to do is bottoms up. So OCP is producing a platform systems and racks. What is the metrics that you want to bring it out of those systems so that you can able to influence the platform and systems to be more efficient. And also we want to look at what is not considered as part of that IT energy today so that you can able to represent it and bring it out of the system and represent it. And as you can see, this is still work in progress. It's not finalized what I'm presenting it. So we would like to all of you to join and help to fine-tune the numbers here, right? So if you're looking at the total active power going to the system, so I'm going to take a system level, then I will represent it at a rack level. If you take a system level, the power going into the system is producing some compute output to the end user. So if you look at what is the computational power consumed by those elements, you can basically classify as a real IT energy that is going to the compute versus non-IT energy that is part of the system but not going to the compute. For example, fan power is not really producing a compute. So you can basically say thermal power or anything related to the power and cooling, or you may have conversion losses, and also you have ideal power in the systems. If you subtract them, that is not really producing the final compute or the efficient things to the user. You can say, you can divide that and you can create a matrix. The way we are looking at it is, you want to put a compute power on the top and the total power of the system on the bottom. So you get a number from 0 to 1. That is the IUE that we are defining. So you can say IUE is going from 0 to 1 and PUE is 1 to infinity. So now, if you are looking at you cannot just define IUE for a system. So you have to look at the load. The reason you have to look at the load is, if you are operating idle power, it's not really producing any output, it's still consuming power. So, and also if you look at the maximum power, it's producing maximum output. But if you are looking at somewhere in the middle, it's not linear. So what you have to look at is when you represent IUE, you have to say what is the load in which you are representing the IUE. And again, if you take that load into the factor, now if you look at rack level and data center level, it's basically rack is built up of multiple nodes or multiple systems. So you can basically sum all the different compute power coming out of each node, and also you can sum all the power consumed by each system. Then you get a system level or a rack level IUE. And again, you can basically say, like, you can also put a factor. If you know each system's IUE and you know the system power, you can compute the rack level IUE. And if you are looking at a data center level, it's the similar thing. Basically, you can sum for each rack, which produces the final data center. You can get a data center level IUE. So basically, like if you are looking at each elements that we talked about, power conversion, ideal power, and as well as thermal power. If you want to represent at a rack level, what you want to do, right? So if you look at power, you could have individual systems powered by its own PSUs, and you have DCTC or VR losses. You can basically take whatever the loss occurred by those individual PSUs plus VRs, you can eliminate that from the total power. So that is one area you can say, like for each system, you can compute it. But if you are going to share the PSU across the rack, like DC bus bar, not one system going to consume the whole thing. If you are operating only one system, it's going to consume whatever the loss occurring on the PSU. You can say it's only consumed by that particular system. But if multiple system is going to share, then you need to have a sharing representation so that you can say, like, this PSU power loss, I'm going to divide across the different systems. And even you can say, I have to divide across the load to represent it properly. And similarly, if you look at thermal power, there are multiple different thermal cooling solutions available. You can say, you can basically have just fan-based, or you can have a hybrid model where you have CDUs, or you have independent cooling per system, or cold-plated, or you can have the basically chiller-based, all kind of things. How are you going to mix? You have different mixing models. You should be able to represent properly on this model, as well as how much power it's consumed by those the cooling elements. Because that cooling you can improve, but unless you can able to represent it and make it available, you cannot really compute. And same thing like for immersion cooling. If you are doing immersion cooling, it's going to be shared across all the systems. Then you're going to have a CDUs for it. And you want to make sure how much power it's going to be consumed by the cooling subsystem. You want to represent that, and you want to take it to at a rack level when you're computing it. And if you are looking at the summary of these different coolings, right? If you have just a fan-based, you may have a 10%. You have a combination of different cooling types that you need to represent that things. Again, depending on how you are representing it or how the systems are composed, you have different power losses that you need to account. And then when you are really looking at metrics needs, for each one you need to start looking into that metrics, how are you going to produce it. If you are looking at power, you have a total system power you should be able to represent it. And also, you need to be able to figure out how much power loss on this different power supplies that you're going to have. You could have a smart power supply that you can able to give you input voltage or input power versus output power. You can figure out the loss for that. If you don't have a smart power supply, you need to understand those power supply losses, and you need to factor in when you are representing that. And also, you can think of each voltage regulators. You can again takes power, and you need to account for what is the loss occurred by those voltage regulators. And similarly, you can even go down to a device level. Each device, how much it's consuming, and how much really power is getting lost in those devices. Then when you're looking at ideal power, this is one of the areas you can really, if you look at the systems, you may have up to like 10 or even more percentage of ideal power consumed by the ideal power of the processors and memory subsystems and all the devices sitting there. You could potentially put a static value depending on how you compute it. Or when you are putting the system, you can measure how much the ideal power is consumed before you start putting any workloads on the system. And you also need to account for all the hot plug or the sharing, the memory is coming pooled and it's coming from somewhere else, how you want to account for it. And if you have, when you have shared storage or network, however you want to account for it. All those things need to be factored in. And similarly, when you are looking at power conversion loss, you also need to look at each power supplies, how you want to account for the loss of power supply, as well as how you want to account for sharing the power supplies. And also, if you are putting fault-tolerant systems, how you want to account for that. Those things need to be represented. And when we are looking on the fan side, again, you can have a dedicated fan per system, or you can have a shared fan. Those we need to represent it, as well as able to show the power numbers consumed by those fans or CDUs. And even if you break down on CDUs, you can again look at your motors and fans, and you can able to really go and find details and figure out how much power is consumed by each one. The reason for putting all these things is to represent from system to a top and to a rack and to data center level. So you can able to compare yourself within the data center. Also, across the industry, people can look at the numbers and see how efficient when you're buying a system or racks. The call to action is, we want you to join the IUE DCEM workstream and enhance this metrics. Let us work together to create a deployable metrics that we can able to represent in the systems, create a Redfish model or whatever the model is needed, so that we can add it to the sustainability profile as part of all the elements what I was talking about it, as part of the profile, so that you can have it as part of one of the elements in the sustainability. I'm ready to take some questions. Thank you.
Hey, Sammy. In the workshop that we had in Oregon, I think there was some questions about whether some of the device vendors for servers had a Redfish profile that actually broke out the fan power. Have you seen that yet, or are people starting to do that? Because I think we asked Supermicro and some other folks. They said, yeah, we don't do that yet.
Yeah, there's two things. One is putting in a Redfish as a representation, and the other thing is people really populating and representing the numbers, right? We have not at least seen putting it, but we are really trying to enhance it much further so that you can represent it, whether really dynamic or static or computed or not. So we are working with the Jeff Warder and John Liang's team to really define the Redfish profile with the additional elements, so that we can able to represent those things, whether it's available or not, for all the different metrics I was talking about it.
Yeah, thank you.
Good.
And if we can make this quite brief, we can do one more.
Hi, Jose from AirTrunk. Just a quick question. You're putting the assumption there that CDUs are considered by the PUE as part of the IT load. So but that's a kind of, I wanted to confirm that, and especially when the CDU is external to the rack. I think when it's internal, it's kind of a difficult challenge, but when it's external, for me, it will be clearly non-part of the IT load. But just if you just wanted to hear of your opinion.
Good point. We don't want double count, right? You don't want to account here and also account there. So it's when you're putting outside your IT workload as part of the representation, you want to put it outside and keep it as a part of PUE calculation, right? But if somebody wants to compare my systems and racks across other vendors, you still need to have some representation you can able to say, hey, this is what the number is going to be consumed, so that I can compare apple to apples, right? That is a motivation, actually.